Some of the biggest mysteries in the universe are all about other questions, like the question, what is it?
It's shedding pure nickel atoms by the billions every single second. As NASA's most powerful telescopes focus on the Interstellar Visitor 3I Atlas, they're detecting something that, according to our best understanding of space rocks, simply should not exist. This discovery has sent shockwaves through mission control. A leading Harvard astrophysicist is suggesting that we aren't just looking at a comet. We might be looking at a piece of technology. The object's unprecedented metal emissions and impossible chemistry have opened a universe of terrifying and exciting new possibilities about who or what sent this thing our way. A warning from Harvard. In the vast silent theater of space, where visitors from distant worlds should behave like the comets we know, something is breaking every rule of cosmic chemistry. On July 1, 2025, the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, first reported observations of Comet 3 I/Atlas. At first, it seemed like a rare but normal interstellar comet, the third confirmed interstellar visitor to our solar system. But as Atlas drew closer, the normal turned extraordinary. You see, when astronomers used European telescopes in Chile to monitor 3I/Atlas as it approached the sun, they found something that left them speechless. The object is producing streams of atomic nickel vapor while showing absolutely no trace of iron, a combination so rare it has never been observed in any natural space object. The real shock came when they analyzed what this meant. In the cosmos, nickel and iron are cosmic twins, forged together in stellar cores and found together in virtually every space rock, comet, and asteroid ever studied. When you find nickel in space, you find iron. Always. Except here. This is where the story takes a sharp turn from cool discovery into profound cosmic mystery. Harvard astrophysicist Avi Loeb, known for his bold and often controversial ideas about interstellar objects, sounded the alarm. He pointed out that the unusual nickel without iron emission from 3I/Atlas breaks every rule of natural space chemistry. The separation of these metals was a red flag of cosmic proportions. Could nature even do this? The question hung in the air, thick with possibility. It was the first clue that 3I/Atlas wasn't just a messenger from another star. It might be a message in a bottle, deliberately crafted and sent on a journey across the interstellar ocean. The thing nobody tells you is that creating pure nickel emissions requires either the most extreme natural conditions imaginable or technology. Between July and August 2025, European telescopes monitored the evolution and found that starting in July at 3.88 astronomical units from the sun, 3I/Atlas began producing nickel atoms. By August, this production had exploded 25-fold in just 1 month. This wasn't gradual change. This was an explosion of metallic activity unlike anything ever seen. Many people are crazy about jumping to alien conclusions, but NASA is by its very nature methodical. They needed more data. As NASA's James Webb Space Telescope observed interstellar comet 3I/Atlas on August 6th, with its near-infrared spectrograph instrument, it uncovered another piece of the puzzle that only deepened the enigma. Within the coma of 3I/Atlas, the mixing ratio of CO2 relative to water is 8.0 plus or minus 1.0. This is one of the highest CO2 abundances seen in a comet. Our comets typically have around 4% carbon dioxide. This thing had 8 times more carbon dioxide than water. It was fundamentally different from anything born in our solar system. It was built differently, it was behaving differently, and it was shedding impossible metals. This was no longer just a comet, it was a cosmic riddle wrapped in what looked suspiciously like industrial chemistry. When objects come from deep space, you expect them to follow the basic rules of cosmic chemistry that have held true for billions of years. But not all things are what they seem. As VLT observations continued, they found that at the same time nickel production skyrocketed, cyanide gas began to appear. First detected on August 14th at 3:07 AU, its production rose to massive levels by August 21st. The staggered appearance of nickel first and cyanide later points to different thermal thresholds or distinct reservoirs in the nucleus. This wasn't random outgassing. This looked organized, sequential, almost like different systems activating at different temperatures. Dr. Avi Loeb, who first raised concerns about the previous interstellar visitor Oumuamua, took another look at the numbers. He calculated that the spectrum of 3I-ATLAS shows substantial reddening. In the absence of submicrometer dust, the reddening must originate from the solid surface of 3I-ATLAS. The thing is, this reddening pattern wasn't like weathered space rock. This is not unexpected since similar reddening is observed from the surfaces of Kuiper Belt objects, like Arrokoth, which are similarly exposed to interstellar cosmic rays. But the intensity suggested something else entirely. Could this just be an exotic natural process we've never encountered, or was something else going on? You see, when Loeb analyzed the brightness data more carefully, he found something that challenged everything. To produce this reddening without shedding submicron dust particles, most of the sunlight reflected from 3I-ATLAS must originate at its surface. It then follows that the brightness of 3I-ATLAS implies a surface diameter of 20 kilometers for an albedo of 5% that characterizes Kuiper Belt objects. But here's where it gets really strange. The flux detected by the Spherex Space Observatory at a wavelength of 1 micrometer from 3I-ATLAS suggests an even larger nucleus with a diameter of 46 kilometers. This implies that the mass of 3I-ATLAS is 1,000,000 times larger than that of the previous interstellar comet 2I-Borisov. The statistical improbability was staggering. When you pile up all these oddities, the impossible metal emissions, the sequential chemical releases, the massive size compared to other interstellar visitors, the strange surface properties, it becomes harder and harder to dismiss the feeling that this is more than just a space rock. It starts to feel manufactured. It starts to feel like technology. To understand the full weight of the 3I-ATLAS mystery, we have to consider what we've learned from previous interstellar visitors. The first confirmed interstellar object, Oumuamua, was discovered in 2017, followed by 2I-Borisov in 2019. Both exhibited properties that challenged our understanding of natural space objects. Oumuamua showed mysterious acceleration with no visible outgassing. Borisov appeared more normal but still had unusual properties. Now we have 3I-ATLAS. And once again, we're faced with an object that breaks fundamental rules of cosmic chemistry. The thing nobody tells you is that in 4 decades of studying comets and asteroids, astronomers have never seen anything like this nickel signature. One strange visitor could be dismissed as an anomaly. But 3 starts to look like a pattern. The detection of atomic nickel in 3I-ATLAS isn't just unusual, it's scientifically revolutionary. The closest comparison scientists can find is industrial processes here on Earth. The signature matches what is observed when nickel alloys are produced deliberately in factories on Earth. Dr. Loeb raised the question that everyone was thinking but few dared to voice. A way to resolve the discrepancy between the mass reservoir of rocky material in interstellar space and the unexpected discovery of a large object that measures tens of kilometers in diameter is that 3I-ATLAS was not drawn from a population of rocks on a random trajectory, but instead its trajectory was designed to target the inner solar system, a cosmic messenger or cosmic technology. So here we are, faced with a visitor from the stars that produces metals like a factory and behaves like no natural object ever discovered. On one hand, we have mounting evidence that points towards something extraordinary. The extreme production scaling, 25-fold increase in 1 month, could potentially reflect designed systems activating rather than natural processes. The idea of a probe deliberately constructed with specific materials is compelling. Perhaps an advanced civilization designed 3I-ATLAS to release specific chemical signatures as a language that any spacefaring society would recognize as artificial. One candidate explanation is nickel carbonyl, NiCO4, an extremely volatile molecule that forms when nickel metal reacts with carbon monoxide. It has a low sublimation temperature, can be released under mild heating, and photodissociates quickly under ultraviolet radiation, releasing nickel atoms and carbon monoxide. But the thing nobody tells you is that even this natural explanation requires incredibly specific conditions. The precision of the chemical releases, the timing, the absence of iron, it all seems almost designed. Then there's an even more profound possibility. Loeb calculated that if 3-ATLAS generates its own light, then it could be much smaller than expected from a model in which it reflects sunlight. The reflection model requires a diameter of up to 20 kilometers, which is untenable given that the limited reservoir of rocky material in interstellar space can only deliver such a giant rock once per 10,000 years or longer. What if the metallic emissions aren't just byproducts, but the primary function? What if 3-Atlas is designed specifically to produce these signatures, to stand out against the cosmic background like a beacon calling out to anyone with the technology to detect it? The missing tail mystery. But there's another piece of this puzzle that makes the technological hypothesis even more compelling. According to new data reported by astronomers, 3-ATLAS exhibits reddening colors with no visible tail detected. When you look at the highest resolution images taken by the Hubble Space Telescope, you see something that shouldn't exist. A comet without a proper cometary tail. You see, when comets approach the sun, they heat up and start shedding material, creating the distinctive tail that points away from our star. It's one of the most fundamental behaviors of these icy visitors. But 3-ATLAS breaks this rule too. Despite being active and producing that mysterious nickel emission, it shows no conventional cometary tail structure. The authors of the study explain these features as being likely due to viewing geometry and low dust production. But when you step back and look at the bigger picture, another explanation emerges. What if there's no tail because this isn't a normal comet shedding ice and dust? What if it's a technological object releasing specific materials through designed vents or systems? The thing nobody tells you is that the spectroscopic data does not show the features expected for atomic or molecular gas in a typical coma. The observed reddening in the spectrum of reflected sunlight from 3-ATLAS could be associated with a metallic surface rather than dust. It's exactly what you might expect from an artificial object with engineered surface properties. This lack of a conventional tail becomes even more significant when you consider the object's brightness profile. Detailed analysis of the Hubble Space Telescope image implies a total column density of dust that's far too low to explain the object's overall brightness. This means most of the light we're seeing must be coming from the object's surface itself, not from scattered dust particles. A thermonuclear mystery. Here's where the story takes an even wilder turn. If most of the reflected sunlight originates from the solid surface of 3-ATLAS, and if that surface has the unusual properties we've observed, then we might be looking at something that generates its own energy. Loeb calculated that the observed luminosity of 3-ATLAS is about 10 gigawatts. That's roughly the output of several nuclear power plants. For a normal space rock, this energy would come from reflected sunlight. But what if it doesn't? What if 3-ATLAS contains its own power source? The simplest interpretation suggests an object radius of 3 to 10 kilometers to account for this brightness through reflection alone. But here's the catch. We would expect to find many more similar-scale interstellar objects before discovering one that's 100 times larger and 1,000,000 times more massive than previous visitors. The statistical improbability is staggering. It's like finding a cruise ship in a harbor full of rowboats. Either we're incredibly lucky or we're looking at something that was specifically designed to be noticed. Some scientists have even explored the possibility that 3-ATLAS could be powered by exotic physics. Before his morning jog at sunrise, Loeb calculated the annihilation rate of ambient zodiacal dust if the surface of 3-ATLAS were made of antimatter. For a nucleus radius of 10 kilometers, the result was a gamma-ray luminosity of a few gigawatts, coincidentally comparable to the power emitted by 3I/ATLAS in visible light. While the antimatter hypothesis is extremely exotic, it illustrates just how far outside normal parameters this object operates. Whether powered by antimatter, nuclear decay, or some other exotic process, the energy requirements suggest technology rather than natural processes. The trajectory that defies coincidence. But perhaps the most compelling evidence comes from 3I/ATLAS's path through our solar system. When Loeb analyzed the object's trajectory, he found something that challenges the random visitor hypothesis entirely. Most interstellar objects should arrive from random directions, following chaotic paths determined by their ejection from distant star systems and billions of years of gravitational encounters. But not 3I/ATLAS. Its orbit is aligned with the ecliptic plane of our solar system, the same flat disk where all our planets orbit. The probability of this happening by chance is incredibly small. It's like throwing a frisbee randomly into the air and having it land perfectly parallel to the ground. If you wanted to design a trajectory to get the best possible survey of our solar system, this is exactly the path you might choose. By traveling through the ecliptic plane, 3I/ATLAS gets optimal viewing angles of all the major planets and can sample the densest region of our solar system's material. The thing nobody tells you is that this alignment suggests either incredible coincidence or deliberate targeting. When you combine this with all the other anomalies, the metallic emissions, the impossible chemistry, the lack of a proper tail, the enormous size compared to other interstellar visitors, the coincidence explanation becomes increasingly hard to swallow. The clock is ticking as 3I/ATLAS approaches its closest point to the sun in late October 2025. We're running out of time to solve this mystery. The object will pass behind the sun from Earth's perspective, making it impossible to observe during what should be its most active period. It's almost as if the timing was designed to limit our observations. After October, 3I/ATLAS will begin its journey back to interstellar space, and we may never get another chance to study it up close. NASA has mobilized an unprecedented array of instruments to observe this visitor. The Hubble Space Telescope, James Webb Space Telescope, SPHERES, and ground-based observatories around the world are all focused on capturing every possible detail before it disappears forever. But even with all this firepower pointed at 3I/ATLAS, we're still left with more questions than answers. The Mars Reconnaissance Orbiter will attempt to image the object when it passes within 29 million kilometers of Mars, potentially providing our best close-up view. These observations could finally determine whether we're looking at the most exotic natural object ever discovered or humanity's first confirmed encounter with alien technology. But not all things are what they seem. Science demands that we explore every natural possibility before accepting extraordinary conclusions. Leading scientists propose that exotic natural chemistry could explain the observations. 3I/ATLAS might contain nickel carbonyl compounds that release nickel atoms while iron compounds remain stable. This would be unprecedented but still natural. The answer is a tentative maybe. It would require the most extreme and specific natural processes to create an object that behaves exactly like 3I/ATLAS. The critical unknown is that, most importantly, iron might actually be present but undetectable with current instruments. The telescopes used have specific limitations, and iron emission could exist below the detection threshold. Perhaps 3I/ATLAS formed in the aftermath of a kilonova, the collision of two neutron stars that can separate heavy metals under the most extreme conditions in the universe. Or maybe it's a fragment from an asymmetric supernova that underwent unusual nuclear processes. These scenarios could theoretically explain the strange metal ratios, though they would require a series of incredibly specific and unlikely events. The possibility that 3I/ATLAS represents some form of natural nuclear reactor also can't be dismissed entirely. Certain radioactive elements could potentially power the object for millions of years, explaining both its luminosity and its unusual emissions. However, The reservoir of such materials in interstellar space is vanishingly small, making this explanation nearly as unlikely as the technological hypothesis. When you look at it that way, the technological explanation starts to sound less like science fiction and more like the most logical interpretation of unprecedented evidence. The question is no longer whether 3I Atlas might be artificial, but what its creators intended us to discover when we found it releasing impossible metals into the cosmic void. The verdict from Harvard. This brings us to the most unsettling possibility of all. When asked to rank 3I Atlas on a scale where 0 is definitely natural and 10 is definitely technological, Avi Loeb gives it a rank of 6. Not definitive proof, but far from ordinary. His reasoning is simple. Every new piece of data moves 3I Atlas further from the template of known natural objects. Loeb points out that asking whether 3I Atlas might be alien technology should not be censored for the simple reason that we must avoid being misguided by prejudice. In science, any question is legitimate. The scientific method allows for all possible questions, which are later answered by collecting data and ruling out possibilities. The resistance from some in the scientific community to even consider the artificial hypothesis is, in Loeb's view, anti-scientific. It suppresses curiosity-driven questions about anomalies before conclusive data is gathered to explain them. Whether the final answer turns out to be exotic natural chemistry or something far more extraordinary, the scientific process demands that we remain open to all possibilities.